A ball is thrown vertically upwards from a balcony of a tall building with a velocity of 12 meters per second. Okay, so let's first look at that. So here we've got the picture of what's happening. And they say that a ball is thrown vertically upwards from a balcony. Okay, so here's the balcony there. And so here's the ball that is being thrown upwards. They told us that it has an initial velocity of 12. Okay. On its way up, the ball passes a window. Okay, so we can see that here is a window, and the ball's going to go past the window. The balcony is 4 meters above the ground. Okay, so let's put that in here. The balcony is 4 meters above the ground. The velocity of the ball at the bottom of the window is 8.1. Okay, so over here, the velocity is 8.1. So obviously it starts off over here at 12. Now let's actually put it in line here with the balcony. And then when it gets to the bottom of the window, then the velocity is 8.1. I'm not going to say meters per second over here. This is just a drawing. Okay. So that's the information that they've given us. And then ignore the effect of air resistance. So that's usually something that they say, don't worry about that. Okay, the first question is define the term free fall. I always struggle to say that. Free fall. Can you say that easily? Free fall. Free fall. I battle to get those words out. I don't know. Maybe it's just me. Maybe it's a common thing. Well, the way I want you to think about it is like this. Let's say you are standing on this balcony. Okay, you're standing on this balcony and you have a ball in your hand. And you are going to throw that ball upwards. Now, when the ball releases or when the ball leaves your hand, then what forces are acting on that ball? Some of you will say an applied force, but that is not correct. Remember that the ball, once it has left the person's hand, then there is no longer an applied force. Now, some of you are like, yeah, but then Kevin, why is it moving, bro? Why is it going up? That's because the person's hand gave it an original velocity or an original momentum. But once the hand is no longer touching the ball, there is no longer an applied force. And that is why the ball actually begins to slow down as it moves up. Okay, so there's no applied force. Please remember that. There's no applied force. Some of you might say, oh, I know, air resistance. But that is correct. But remember in grade 12, we ignore air resistance. And then, so then what else is there? Well, the only other force is gravity. And that is what this chapter is all about. It's about looking at situations where you've got objects moving vertically under the influence of gravity only. So what is free fall? It is motion under the influence of gravity only. Okay, let's get into some calculations. Calculate the time taken for the ball to reach its maximum height. Okay, so that means from, let's go get our formulas first. Okay, so I've just put all of these formulas over here. Now remember, underneath this table, there was some other text under this table for this question over here. For those of you that maybe want to go ahead or, just remember that there is still text under here. Okay, so I'll take this table away soon. So it says here, calculate the time taken for the ball to reach its maximum height. So we know that the movement starts over here. So we can let that be our initial position. Okay, so I've got VI over there. Now we know that the ball's going to go up, and eventually it will come to a stop, right? That's what happens. The ball goes up, and then when it reaches its maximum height, it has a velocity of 0, and then it immediately begins to turn around and then starts coming down again. So at this point over here, I'll call this VF, and I know that its velocity there should be 0 or will be 0. Okay, so they want us to calculate the time. So I definitely think this will be the most straightforward equation. So I'm going to say VF equals to V initial plus A delta T. So that's first step. Write your formula. Second step, choose a direction. I'll choose upwards as positive. Okay, you can choose down as positive as well. There's nothing wrong with that. So the final velocity is 0. The initial velocity is 12. Acceleration is always going to be 9.8, but you need to think about this. Acceleration, gravity, or gravitational acceleration always acts in which direction? Well, if you forget, just quickly get up during your exam, quickly jump and see what happens. Where will you go? You're going to land up on the ceiling? If you do, call me. I want to come to your school. That is awesome. But no, in most schools, I guess if you jump up, what's going to happen? You're going to land on on the floor. That's because gravity always acts down, no matter what. So we chose upwards as positive. So gravitational acceleration, because it acts down, we will have to put a negative over here. And then we're just going to put delta t. So this part here is just going to become 9.8 delta t. Or negative 9.8 delta t. Because a positive and a negative there make a negative. Then I'm going to take this over to the other side. So we're going to end up with 9.8 delta t equals to 12. And now it's just a matter of dividing both sides by 9.8. So we can get delta t by itself. And to 2 decimal places, we end up with 1.22 and then seconds. Okay, so we'll put here 1.22 seconds. Now, when we move on to further questions, or no, I'll mention this when we get to these specific kind of parts. I just don't want you to be in the habit of saying, okay, so this is always going to be my VF now. That's not necessarily true. They might ask us a different kind of question later on where we no longer want this to be our VF. The only reason I made this the VF for that question was for that question, they were only looking at the movement from where we started up until this part. So for that question only, I liked to have this as my VF. But if they ask a different question later on, where maybe they ask the time to reach the ground, for example, well then the ground will become my new VF. So don't think that your VF is like a fixed place. Okay, not even your V initial is a fixed place. Maybe you do a question later on where they want to know how long does it take to go from here down to the ground. Then this would be your initial and this would be your final. So I want you to understand that your initial and final positions are not fixed. They are only fixed for each question. But as you move on to a next question, those things can change, okay, depending on what they ask. Okay, so moving on to this next one, this one over here. What is the maximum height reached by the ball? Okay, so the maximum height is also going to be somewhere over here. So I'll call this my VF again, and then I'll call this my VI. Now they want height, which is this delta X, or, you can use the ones with X or the ones with Y, but you don't have to choose one or the other. Some learners message me and they're like, Kevin, don't we have to use Y because we're vertical? And no, if your teacher's saying that, maybe they're just trying to be technically correct, but in the exams, like in your final exams, they don't mind if you use this one or this one. It doesn't matter. Okay, that's why they even say here, or. It doesn't really matter at all. Okay, so what is the maximum height reached by the ball? So we know the time, but I sometimes try to not have to use previous answers because maybe you weren't able to solve that one. Okay, but I mean, if you have to and if you want to, you can. But for example, I would rather go with something like this. Look at this bad boy. Because now you can just go type in the formula or write it out. Now we have all the information already, and it's information that they gave us, so we know that we have it at least. So the final velocity was 0. We know that at this point the final velocity was 0. The initial velocity, that's still going to be 12. Oh, I didn't even choose a direction. Let's keep up as positive. And then the acceleration will then be a negative, and then delta x we can just leave like that. So this will end up giving us 0 equals to 144. Now this becomes negative 19.6 delta x. And then we're going to take the 19.6 over to the other side, or the 19.6 delta x equals to 144. Divide both sides by 19.6. And end up with delta x equals to 2 decimal places 7.35, and that's measured in meters. Okay, So there we've got that one, 7.35 meters. Okay, now we're moving on to this question over here. It says, what is the time that the ball takes to reach the top of the window? Okay, so they want to know what is the time from the beginning until the ball reaches this level over here. Okay, so what we could do is, let's forget about this VF now. Let's make the VF this part over here. And what we can do is calculate the time to go from here to here, because we know the initial velocity and we know the final velocity. So we could easily use this formula to work out the time. So we could just write out the formula, choose a direction as positive. Let's choose up as positive. So the final velocity is 8.1. The initial velocity is 12. Acceleration will be negative 9.8 because we've chosen upwards as positive, and acceleration always acts down, and then we can work out time. So now that is going to work out the time between those two levels. Okay? And so I'm going to take this over to the other side, and I'm going to bring this over to this side. So you're going to end up with 9.8 delta t on the left, and 12 minus 8.1 on the right. And so on the left we have 9.8 delta t, and then on this side we have, what is that, 3.9. Let me just double check. 3.9, okay. And then if we, to get delta t by itself, we divide both sides by 9.8. So delta t will be, and this is not the final answer, hey? Okay, so I'm gonna keep it. I'm not gonna round off. So we're gonna get 0.39795 on and on seconds. Okay, we're going to keep that number because that is not the final answer. That is just the time from this level up to this level. Now, but they want the time to go all the way to there. Now I'm going to restart, or not restart, but now I'm going to let this be my initial, and I'm going to let this be my final position now. Well, I'm not going to say V because I don't know what the V is, but this will be my final position, and this will be my initial position. But now I know the distance from there to there. So now we need to think about which formula we could use. So I think, oh, this one here would be perfect. The reason is, let me explain why I like this one. Because we know the distance from there to there, we know the initial, but we don't have the final. But luckily, this formula doesn't need the final. And then we're trying to work out the time. And so we have this, and we have A. And so we can work out time. Once we have the time for this piece, then we simply have to plus that with the time for this piece. And that'll then give us the time for the entire part. So this one here would be the best. But I was just thinking about it now. There are other ways. If you use this way, which I think I will do, we're going to end up with a quadratic, and that does put some learners off, and I can understand that. But what you could do if you want, if you don't want to do a quadratic, is you could have used this formula over here to calculate VF, and then you can come up to this formula here, and then you can calculate time. That might even be better, because then we don't have to use a quadratic expression. So you can do whatever you want. I think I might even do that actually. I'm feeling like I don't really feel like doing a quadratic right now. So maybe we go ahead with this one and then you do this one. But like I said, if you want to just go straight to that one, you can. So that answer that we got over here, remember we had this long answer like 397 blah, blah, blah. A nice little thing we could actually do is, if you press SD on your calculator, switching it from, or to the decimal, or I don't even know what that thing means, but switch it to the fraction, you can see that it's 39 over 98. So maybe we could just write it as 39 over 98, because that is a lot easier to write instead of having to write this whole thing. Okay? So obviously see what your teachers would prefer, but for now I'm just going to write it as a fraction, so it's much shorter. Okay, and that was just this little delta t1. I'll just call that delta t1. Okay, so we said that we can go use those two formulas. So I'm going to use this one first. Okay, and I'm going to choose upwards as positive. Now, we don't know what the final velocity is. Remember, we're not going to say 0. That was only the final velocity when we were looking up here earlier on. But now we're in a new part of the question. Okay, so the initial velocity, now be careful. we're trying to calculate the time for this piece over here. So this is now your initial. Don't say 12. 12 was the initial for a different part of the question. That's important that you understand that. Acceleration is 9.8. And now, we do have the delta x. It's 1. Okay, so now you can literally just go type this all on your calculator in one big step. So I'm going to go do that. And that'll give you 46.01. Now you need to take the square root to get the square away. And so the final velocity at that point is going to be, okay, so this is another long one, so 6.783067153 meters per second. Okay, now that is the final velocity over here, 6.78. Right, so now what we can do is, I'm just going to take this away, 39 over 98. 39 over 98, 39 over 98. Okay, don't want to forget that. Now we can go use the this other formula, VF equals to V initial plus A delta T, choose up as positive. And so the final velocity now is 6.783067153. The initial velocity is 8.1, acceleration negative, and then time is, that's what we're calculating. And so, okay, now this is going to become negative 9.8 delta t. So I'm going to take all of this to the left, and then I'm going to bring all of this to the right. So we're going to end up with 9.8 delta t equals 8.1, take away 6.783067153. And so you'll minus these two together on your calculator, and then you'll divide by 9.8. And what we should end up with is a delta t. This is not the final answer. This is just the delta t. Let's call this delta t2. So delta t2. And that's going to be 0.1343809.028 seconds. Now I got something really interesting I need to talk about. On the memo, I don't agree with what they've done. Maybe you've looked at this exam paper before. They only give this as the final answer. What they are doing is they are only calculating this time over here. But that is not what they said in their question. The question says, calculate the time the ball takes to reach the top of the window. Naturally, what that means is from the moment it was thrown upwards on the balcony. If they wanted us to only calculate this time over here, then they should have said the time the ball takes to reach the top of the window from the bottom of the window, or something like that. So I think they might have allowed the learners to answer it the way we've done as well, because I'm sure there was a huge uproar about that, because many learners would have done it the way we've done it now. So yeah, trust me on that. They would definitely have made some corrections to that, because I'm sure that most people, when you read this, you would think it's from the time from the balcony. So to go work out this final answer now, we're just going to add up the time that we got at 1 plus the time that we got at 2. And so that's going to be this plus this. And that will give us, to 2 decimal places, 0.53 seconds. Okay. So as I said, on the memo, they only give this one, which is the time just from the bottom of the window to the top of the window. But that is not what this question is asking. So they've made a bit of a mistake there. You can trust me on that one. Okay. Okay, so now we're moving on to this one. It says, draw a velocity versus time graph for the motion of the ball from the moment that it is thrown upwards until it comes back to the position it was thrown from. Use the point from which the ball was thrown as the reference. Clearly indicate the following on your graph: the velocity with which the ball was thrown upwards, the time taken by the ball to reach its maximum height, which was this value here, and then the velocity with which the ball arrives on the ground. See, I don't agree with this question either. They tell us that they want us to draw a velocity time graph from the moment we throw it until it comes back to the original position. So that means it's not going to go down to the ground, but yet they want us to show the velocity on the ground. It's a bit weird. I went and looked on the memo. This part here is a mistake. The velocity with which the ball arrives, rather replace that with back at its, or let's just see, use the point, comes back at its position it was thrown from. Okay, not the ground. We're not going down to the ground. All right. Ooh, a lot of mistakes I see in these exam papers. It's not good. Okay, so all right. So it's a velocity time graph. So we're just gonna draw a y-axis and an x-axis. X-axis is time. It's so fun when you're doing this part of the exam. It's like procrastination. Don't have to start the question just yet. Can avoid it as long as possible by just filling in my y and x-axis. Okay, now let's choose up as positive because that's what we've been doing for the entire question. So it's really easy, guys. Check this out. What was the original velocity in the very beginning here? Well, we know that that was 12. So just go to, and was it 12 up or 12 down? It was 12 up, and we chose up as positive. So you can just go to the 12 on your graph over here and put a little line there. Okay. If we chose down as positive, then up would be negative, and then you would start here at negative 12. But that's not what we did. Okay, now immediately, what is that ball going to start doing as it starts going up? Is it going to speed up or is it going to slow down? It's going to start slowing down, so your graph is going to go like that. It's not going to go like that, because then the graph is becoming, or the ball is going faster, because then it's going 13, 14, 15. Instead, we want to go 11, 10, 9. We want to slow down. And it'll keep slowing down until it reaches its maximum height. Can you remember what the velocity is at a maximum height? 0. Well done. So we're going to go all the way down to our graph, because here the velocity is 0. Now, what would happen at that point? Well, the ball would turn around and it would start going downwards. So because it's going down and we chose up as positive, suddenly your velocities are going to become negative. And it's actually just going to keep going all the way down, 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 until it reaches back to the balcony again, where it would have the exact same velocity that it started with, which would now just be negative 12. So we can just go all the way to there, and then this can just be negative 12. Now, let's make sure we've showed everything. The velocity with which the ball was thrown upwards, yes, we showed that. The time taken by the ball to reach its maximum height, which is over here, and that time was 1.22. So we'll just show 1.22. Okay. And then the velocity with which the ball arrives back, yes, we've got that as minus 12. That's it.